The good times are killing me. Do, 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 do. The good times are killing me. Olá pessoal. So section 2.5 has us dealing with these equilibrium differential equations and determining whether or not they are stable. Again, I will link a video in the description that kind of goes into the greater detail of what's going on, but I've kind of boiled it down to the clip notes, and I just want to run through an example that you might see in the homework or the quiz, you know, the real important stuff. So let's go about doing that. So we see that we have a differential equation here, and it is split up into factors, and that is done intentionally. Essentially what we're going to be doing is using calculus 1 concepts, particularly that of critical points, to kind of solve these guys. So let me show you what I mean. So I'm going to go ahead and pick the smallest critical point, and we can tell it's going to be this guy because we have y equals 7 here, y equals 3, and y equals 1 here. So let's do this guy. So I'm going to say at y equals 1. That's a handsome looking 1. So I don't know exactly what these number lines are called, but how I know they work is we're going to choose 1 in the middle, and then we're going to choose a number bigger than 1 and a number smaller than 1 to kind of go on either side. And so let's do 2 and 0. That's perfectly fine. So now all we're going to do is we're going to plug in this value into every y there to kind of see what the sign is going to give us. We don't care about the actual value. We don't care about the number. We just care about the sign. So let's go ahead and plug in a 0 for every y here. So we got 7 minus 0. That's going to be a squared every single time. So that's always going to be positive. So every time we do this, let's just consider this positive. So positive, that's going to be positive. 3 minus 0 is positive. 0 minus 1 is negative 1, so it's going to be negative. So we've got a positive, positive, negative. So this is going to be negative. Okay, let's do the same for 2. So positive, positive, positive. So we got a positive, positive, positive. Good stuff. Okay, now these charts are kind of where the money is, and let me show you exactly how we use these to determine stability. So we're going to put our number in the middle here. This kind of represents our critical value, this line, the central line. And this quadrant up here kind of represents every value that is past our critical value. So basically these guys. And we notice it's a positive. That means we have a positive slope. So we're going to be going this way, which is very cool. And then we have a minus down here. So that means in this kind of area below our critical value, we're going to have a negative slope. Okay. So what we have here is kind of flail out shape, and I think the correct term for this is unstable. Basically, whenever you see like that, like I said, that flail out shape, where it kind of like is being like magnetically repelled from like this middle critical value, that's how you know it's unstable. I don't know exactly what that means as far as, I mean, I totally do. I'm just not going to go into detail about it. Blue, yes, got it. Okay. I like going in numerical order. Numerical. I like going in numerical order. The bigger number. So I'm going to show you this guy. So I'm going to say at y equals 3. Again, 3 is going to go in the middle. Now we have to choose a number smaller than 3 and bigger than 3. I'm going to go ahead and choose 2. That is absolutely fine to do, and it's kind of recommended because we already know what the sign is going to be when we plug it in. So that's going to be positive. And took a gander at 4. So we got positive. 3 minus 4 is negative, positive. So this is going to be a negative. Okay, so what does this represent graphically? Okay. So if you choose a value above our critical point of 3, it looks like we're going to have a downward slope. So something like this, where it kind of converges onto the critical point. This guy right here is a positive. So what this is saying is we kind of have this positive slope where we, again, converge on our critical point. So the term for something of this shape, where this like convergence happens from both sides, is called stable. This is a stable critical point, I guess. Yeah. So there's 3 possibilities of something can happen. We could have unstable, stable, and if I chose the correct equation, then we should be able to get the third one here. Row-ho. Got it. Okay, so I'm gonna say we're gonna choose at y equals 7. Bam. Okay. So choose a number before 7. I'm gonna choose 4 because we already know the sign. And I'm gonna choose a number after 7. Let's go with 8. Positive. 3 minus 8 is negative. 8 minus 1, positive. So we're gonna have a positive, negative, positive to give us a negative overall. So we have a negative and a negative. Okay, so what's this shape gonna look like? So above our critical value, so in this region up here, it looks like we're gonna have a downward slope going towards our critical value. You know, straight those are. And it looks like below our critical value, so kind of in this region right here, we're also gonna have a downward slope, so we're gonna look something like this. My neighbors are very loud. So they're kind of going in the same direction, like kind of. We can't exactly call it stable because they're both not converging on the same point. They're kind of going in the same direction, but they're not converging at the same point. So mathematicians are kind of lazy, so we say this is semi-stable. Semi-stable, bam. And that's pretty much it for 2.5. I mean, there's a lot of nuances I didn't cover, and like I said, obviously this is probably not going to get you all the way through the homework, but if you are struggling like I was, this can give you a pretty good start. So hopefully this is helpful. If you guys don't think I know what I'm talking about, I will link a video in the description of someone that does, and hopefully they can help you out. But like I said, I hope this is helpful. I will be posting a 2.3 applications video tonight as well. So look forward to that. Yeah, thanks guys.